what you have in front of you guys is the next quiz that we're going to do on UH. It's called Graphing Sine and Cosine. And I was just going to just come in here and I was just going to just say, just take care of the UH quiz, log in and do it. But then I thought about it and I'm like, you know what? It's probably better if I just go over it really quick. So let me go over it really quick. That way we don't have any issues with any of the questions. And plus I'm recording this so you can watch it on YouTube if you have any issues. So the first one, guys, so here we go, focus. It says find three angles, two positive and one negative, that are coterminal with the given angle pi over 2. So coterminal just means I want the same angle that produces the same ray, or the same ray pretty much. So I have pi over 2, so everyone knows that. That's right here. That's this one. And I want two other angles, two positive, and then I want one angle that's negative. So all you're going to do is a revolution. So if I go another revolution like this, look, I'm back at that same ray. Do you guys see that? All right, some of you guys are going to get questions in degrees, and some of you guys are going to get questions in radians. Relax. So if I want another angle that's the same ray, I just go another revolution. So I go plus 2 pi. How do I add them? I get a common denominator, so I turn this into a 4 over 2. See? 4 over 2, 4 divided by 2 is still 2, so I'm adding 2 pi to it. So I go pi plus 4 pi, or pi over 2 plus 4 pi over 2, 5 pi over 2. That's one of my answers. Delete, maybe. So you can delete letter A. Next, I take the 5 pi over 2, and I'm going to go another revolution. So I'm going to add 4 pi over 2. So 5 pi plus 4 pi. Yeah, so keep the denominator, so 9 pi over 2. And so let's see, maybe out, so it's between B and E. So now start with the original, and I want one that's negative. So instead of adding 2 pi, I'm going to subtract 2 pi. So here I am, that's 4 pi over 2, that's the same thing as 2 pi. And then 1 minus 4, that's negative 3. So negative 3 pi over 2, keep the denominator. And letter B doesn't have it, so it has to be letter E. If you get degrees, you're not going to add 2 pi, you're going to add what? 360. If you get degrees, you're going to add 360. Are we clear on that one, guys? Okay, let's go to the next one. Name the quadrant. So before we continue, maybe some of you forgot about the quadrants, or maybe you never knew it. You label the top right corner as quadrant 1. You label the quadrant on the left here, immediately to the left of that, as quadrant 2, where the x's are negative and the y's are positive. This is quadrant 3, where the x and y are both negative, and this is quadrant 4. And use Roman numerals. All right? This means where is sine positive? Sine theta is positive. Remember that sine is the same thing as what? Y. Perfect. Let me rewrite the positive word here. I don't like the way it came out. Positive. All right, so I want to know where y is positive. Well, y is positive in quadrant 1 and in quadrant 2. This one here means where is cosine theta? Negative. That's what it means to be below 0, guys, or less than 0. If you're less than 0, you're negative. So, where is the x values negative? In quadrant 2 and in quadrant 3. Which one has both of those? Quadrant 2. Not bad, right? Pretty simple so far. So this is probably the hardest one in here. And you'll see it's not that bad. It's just we're just going to have to take up a lot of space. So I'll write it up here, guys, because it won't take up that much space. So here we go. It says, let P equals XY denote the point where the terminal side of an angle theta meets the unit circle. If P is in quadrant 2 and X is negative 3/7, evaluate the 6 trigonometric functions. Okay, so I'm coming up here because I have a lot of space over here. So here we go. Here's my grid. And here is my unit circle. And I terminate in quadrant 2. So this is the angle they're talking about. But I'm using the reference to help me out. This is a 1. And the x value, that x value up here is, I think they said negative 3/7. Negative 3/7. I need to figure out what the y value is. What theorem can I use? You're probably doing it also in physics, I think, because I saw him doing some sine, cosine, tangent stuff. Pythagorean theorem. So if I want to know what the y value is, here's what you do. Ready? I'm going to write it here. I'm going to write negative 3/7 squared plus y squared equals 1. I'm trying to solve for the y value, guys. So I'm going to move this to the right. So I'm going to have y squared equals 1 minus that negative 3/7 squared. No, it does not turn to a positive because that squared, that negative squared is going to turn to a positive. It's still a minus. So y equals the square root. I'm going to write it as 1 minus, and then I'm going to square this. Oh, by the way, in case you're wondering why did I not put a square on the 1, that's because 1 squared is just 1. So yeah, I need to be more specific. A squared plus b squared equals c squared. That 1, when you square a 1, it's still a 1. So negative 3/7 squared is 9 over 49. And then 1 squared is just 1. Yay or nay? All right, here we go. Here's your algebra. I'm turning that 1 into 9 over 9. Nope, not 9 over 9. I want the common denominator. 49 over 49. Yeah, sorry guys. Common denominator, I want that. It was a 49. You can really turn that 1 into whatever you want, but it doesn't make sense to do 9 over 9. 49 over 49. When you do that, here's what you get. Y equals the square root. 49 minus 9 is 40 over 49. Then you do your law of exponents. Y equals the square root of 40 over the square root of 49. Have I tricked anyone? Okay. Yeah, that's your law of exponents. The square root of 49 is 7. And I know 40 breaks down 10 times 4. One of those is a perfect square root. What's the square root of 4? So 2 root 10 over 7. That's what your y value is. 2 root 10 over 7. Because this is a unit circle, we can say that cosine is your x value and sine is your y value. So come back over here. And I guess you could have just done it by eliminating answer choices. Cosine is your x. So cosine is negative 3/7. Maybe. Letter C, delete. Letter D, delete. Letter E, delete. It's between A and B. I go to sine, and sine better be a positive 2 root 10 over 7. B is the only one that has that. If I would have been in quadrant 3, then I would have looked for a negative. But I'm in quadrant 2. Sorry. You guys okay so far? All right. Question 4, guys. It says, all right, guys, focus. We're almost done. We're almost done. Rewrite the following expression in terms of its reference angle, deciding on the appropriate sign, positive or negative. Tan 164. 164 is in quadrant 2. You are, let's see, how many degrees are you away from 180? 64, 74, yeah, 16 degrees. In quadrant 2, is tangent positive or negative? Tangent is, y divided by x, which is negative. So, if I use the 16, that's what they want me to do. They want me to use the reference angle. So, if I use the 16, I better put a negative in the front. Because y divided by x is negative. Does that make sense? Oh, it didn't make sense? Okay, sorry. There it is. Yeah, if something doesn't make sense, guys, you guys need to tell me. Okay. All right, we get another chance right here in case you didn't want to ask. Okay, question 5. Rewrite each expression in terms of its reference angle, deciding the appropriate angle. They want cosecant 5 pi over 6. That's in quadrant 2, so I'm just going to exaggerate quadrant 1 and 2. Here we go. There's 5 pi over 6. Here is my reference angle. I am 1/6 pi away from a perfect pi, so this reference angle is pi over 6. So cosecant, so I'm going to write it right here. Cosecant of 5 pi over 6 is the same thing as writing cosecant of pi over 6. Now, before I put a positive or negative in here, plus or minus, question mark. Cosecant's a reciprocal of sine, yes or no? Is sine positive in quadrant 2? So then that means cosecant, and so that means that cosecant of pi over 6 should give me the same value as cosecant of 5 pi over 6, because they're both positive. Cosecant's reciprocal of sine, at pi over 6, what is it, half? Sine of pi over 6 is a half, right? So that means cosecant of 5 pi over 6 is 2. So cosecant of pi over 6 is also 2. Do you see how this works, guys? Okay. Or not? It's not making any sense? Okay. Sine of pi over 6. Do you know what this is? What is it? Okay, it's a half, right? All right. Don't worry. Don't worry. Cosecant of theta is equal to the reciprocal. Cosecant of theta is equal to the reciprocal of sine, right? So the reciprocal of half is just 2. So if I write cosecant of pi over 6, you're going to tell me 2, right? Okay, now check it out. Ready? If I told you, if we were taking a unit circle quiz, and I told you what is sine of 5 pi over 6, you would also tell me half. So if I say, what is cosecant of 5 pi over 6, you're going to tell me 2. Now check it out. Cosecant of pi over 6 is 2. Cosecant of 5 pi over 6 is also 2. Are they the same? They're the same. So if I just use pi over 6 as my reference angle, cosecant pi over 6 is the same as cosecant 5 pi over 6. They're equivalent. All they're asking is, can you give me cosecant of pi over 6 and tell me whether it's positive or negative? It would have been negative if I would have been in quadrant 3. Because pi over 6 is always positive. Anything in quadrant 1 is always positive. Every time you use your reference angle, the output's always positive. You know what I mean? Okay. Look, it gets easier. It gets easier. It just looks like a fancy word, guys, quadrantal angle. For the quadrantal angle pi over 2, give the coordinates of the point. So all that means is I have an angle. Where's pi over 2 at? Right here on the unit circle. What is that coordinate of pi over 2? What? The coordinate, yeah. 0, 1. Perfect. Look for 0, 1. Delete anything that's not 0, 1. Out, out, out. It's between B and E. And then it says, then give the sine and cosine of that angle. Okay, well, that's simple. Sine of pi over 2 is 1. And then cosine of pi over 2 is 0. And just look for that. So this one right here. How do we feel? Not bad? Okay. All right. So we kind of haven't really touched, what we did, we've touched on this, but we haven't really talked about the domain and range of inverse functions. So I'm going to help you out, and I'm going to tell you what answer you should be looking for. All right, so what this means here, this means this. Sine of some angle equals negative square root of 3 over 2. Now this angle, I want this angle to be between, let's see, what gives me all my y values? Between negative pi over 2 and pi over 2. Now, I know some of you guys are thinking, well, Chav, I know where this is negative square root of 3 over 2 in quadrant 3 and quadrant 4. And maybe you're thinking about those two down there. And you're right. This is angle 5 pi over, that's a 3. So 4 pi over 3. And this one over here is 5 pi over 3. And you might see one of those answers in there. Okay, it's not in there. So how do I get another answer? Well, I can do this, guys. You can go clockwise. And that, if I go clockwise, is negative pi over 3. And negative pi over 3 is in the domain between negative pi over 2 and pi over 2. Do you see how we did it, guys? Yeah, sometimes you will see 4 pi over 3 and 5 pi over 3. I think the next answer, I think question 8 has an answer, and I'll tell you where to look if it's sine or cosine. All right, for this one, arc cosine, you're going to look between 0 and pi, because that's going to give you all the answers. In quadrant 1, cosine is positive. In quadrant 2, cosine is negative. All right, so here we go, guys. What this means is this. All right, focus, focus, guys. Cosine of some angle equals negative square root of 3 over 2. All right, on the unit circle, where cosine negative square root of 3 over 2? Bam and bam. What is this angle? 5 pi over 6. That negative 5 pi over 6 is also correct. That's negative 5 pi over 6. That negative 5 pi over 6 is also correct, but we want an answer between 0 and pi. Cool or not cool? So if it's arc cosine, I'm looking between what and what? And if it's arc sine, I'm looking between what and what? Two pi over 2. So make sure you have those notes there because they're gonna probably try and trick you in some of them. For arc tan, you're looking for answers. So theta, so I'm gonna write tan theta equals square root of 3. For arc tan, you're looking for answers between actually not equal to because it's undefined. Negative pi over 2 and pi over 2. Yeah, you actually can't equal negative pi over 2 or pi over 2 because you're undefined. Arctan of square root of 3. So what that means is this, guys. The only way to get a square root of 3 is to get a square root of 3 over 2 in the numerator and a half in the denominator. So remember that tan is y divided by x. So where does this happen? In what coordinate do I have an x coordinate that's a half and a y coordinate that's a square root of 3 over 2? First quadrant, what's the radian? Pi over 3. There it is. There it is, guys. Pi over 3. Good job. All right, here we go. Look, here's arc sine again. So remember, what did we say about arc sine? We're looking between negative pi over 2 and pi over 2. So sine of some angle equals negative 1. On the unit circle, let's see, did they try? Yeah, they did. See, this is why it's good that you wrote that. On the unit circle, what happens there? If I'm looking between 0 and 2 pi, that happens at 3 pi over 2. But is 3 pi over 2 an angle that I'm looking for? No. It has to be between negative pi over 2 and pi over 2. So the only answer I can choose is negative pi over 2. See? By the way, 3 pi over 2 is a correct answer, but not when you're looking at the main branch. And we'll talk about that when we look at domain and ranges of inverse functions. Cool or not cool, guys? The principal branch is what it's called, if you want to Google it. All right, it gets back to easy. Look at these. Find the period of the following function. All right, look, point of inflection going down. Don't make life hard on yourself. There's that one going through the origin. Look for another one that's point of inflection going down. Where does the next one happen at? So what's the period? 4 pi. Look for 4 pi. Done. That's it. Go to the next one. Find the amplitude. Yeah, the amplitude is just 1, guys. The midline's right at 0. The difference between 1 and 0 is 1. The amplitude is just 1, and that's it. Easy or not easy, guys? Go to the next one. Find the period. This is your B. That's where you get your period from. I'm going to write period equals 2 pi divided by 1/3. Keep, change, flip. Or if you just see it, just 2 times 3, right? 2 pi times 3 over 1, that's 6 pi. So what's the period? 6 pi. All right, go to the next one. Yeah, we're going pretty fast because the rest are pretty simple. Find the amplitude. The amplitude is in front of the sine. What's the amplitude? Half. Done. Next one, again, find the period. Look for the coefficient in front of the x. Look for that. That is not the period. That's the b. So to get the period, that's pi over 5, right? So to get the period, you go 2 pi divided by pi over 5. Keep, change, flip. 2 pi times 5 over pi. Pi's cancel out. You get 10. And there it is. See? Find the amplitude. Again, we just look for the number in front of the cosine. What's the amplitude? 9. Yeah, too simple. Okay, this is probably the hardest one. This is probably the hardest one in the whole thing. It says find the shift. Some of you are going to say pi to the left. It is not pi to the left. It needs to look like this. A sine B, open parenthesis, x minus c, close, close, plus d. Does it look like that? Yeah, it doesn't look like that. That looks like this. This looks like a sine bx plus or minus c, I guess, plus d. That looks like that. It does not look like this. So what I got to do, I got to factor out pi over 4. So here, I'm just looking at the inside, guys, because that's what determines my shift. I'm factoring out a pi over 4. So then this will be x plus, because that plus symbol is that plus symbol. And it just says pi, so the only way to cancel that, like there's not a number in front of it, so I got to put a 4 there. That's the only way when I distribute, see? When I distribute, that's pi over 4x plus pi, which is that. So now that I have it in factored form, how many times did I move? 4 times to the left. The sine function moved 4 times to the left. Cool or not cool? Yeah. Okay. No, yeah, the rest are basic. Look, check it out. Question 18. Yeah, you're done. The rest are simple, super simple. Vertical shift. You just look at way over here. What's that vertical shift? 6 up. Done. And then these, relax. Oh my God, Chav, I'm gonna need my calculator. No, you don't. I have yet to see one that you don't need, that you can't just find with basic clues. Find the middle. Find the middle. The middle looks like it is at -1. So anything that does not have -1, delete. Delete, delete, delete. It's between B and D. Find the amplitude. From -1 all the way to 1, what is that gap? 2. So it has to be letter D. Do you see how we did it? Okay, we're going to give you another chance. Yeah, I can't talk today for some reason. Find the middle. It's the same thing. They want another equation. Find the middle. Where's the middle at? 1. So look for +1. Delete A, delete B, delete D. Look, it's 50-50 chance. Find the amplitude. From 1 all the way to 3, what's that distance? 2. So what's my answer? Do you see how simple we got those? All right, guys, we're done. Take care of UH quiz. Make an attempt today. We have many high grades. There's already some hundreds. And yeah, it's due next week, but make an attempt today, guys.